Hello, Oscar, Dario. Hello, good morning. Welcome to class. Okay. So, we start, okay? I'm going to call the roll. So, Lorenzo, Bini, you're here. Aaron, you're here. Dario Gomez. And Oscar, you are with us, okay? Good. So, okay. So this is the planning for today. Today, what we have to cover is Minute Unit 3 examples. Some of you have already done the dynamic version, but I will explain to you because I understand that logic gates is a unit that you really don't know what the unit is about. Okay, so just for giving you another point of view. So in this one, what we are going to call, I'm going to make an introduction to this mini unit, to examples. Okay, and you have to, what I'm expecting from you is that you cover the dynamic version of this mini unit. In fact, we will do it together. Okay, so okay, so if you remember, just an introduction, this weird topic is about what we call logic gates. Okay, so logic gates are a kind of integrated circuits that we use them in a specific needs. Okay. Oh, sorry, this one is in Spanish. Okay, I will change it. Okay, and logic gates. Okay, so remember that for special needs, we are going to use a specific integrated circuits that are going to fulfill a specific functions. I taught you about, for example, for washer manufacturing or for forks manufacturing or for many metal manufacturing objects, we use press. A press has two molds, an upper mold and a lower mold. Just by pressing the upper mold against the lower mold, I obtain these shapes. Okay. What is the story about integrated circuits? This is a press. Here you have the upper mold and here you have the lower mold. And the operator, the one that is going to operate the press, will be here. It is a strong machine, so it is risky. That's why we need that the motor has to be on just in case the operator has both hands in a secure position, pressing A and B, push buttons. Okay? So we want the motor to be on just in case the operator is pressing A and B simultaneously at the same time. Okay? This is one of the needs that we have. Okay? This is one of the examples that we will cover in this mini unit. Also the escalator. The escalator, in this one we have another need. Okay, the need is a little bit different. Okay, okay, in the escalator, the motor of the escalator will be on all the time. Okay, will be on all the time. But in case of an emergency, you have two different places for stopping the motor, whether A or B. So in the previous one, you have to, the motor is activated if you press A and B, and in this case, the motor is stopped whether if you press A or if you press B. So the need is a little bit different, but will be covered with another integrated circuit, different but more or less with the same idea. The idea is that the integrated circuit will give us a response depending on the inputs. Okay, the idea is always the same. Depending on the inputs, I have a different output. Okay, in this case, the inputs have some schedule, and in this one have another schedule. But the idea is the same. Depending on the inputs, I have different outputs. Okay, so this is what we are going to cover here in different examples. The next one is the elevator. The next one is the elevator. Okay, we will cover it through the mini unit. Okay, so in a two-hand control, remember that the motor will be on just in case we press A and B at the same time. This symbol is representing an AND gate. Okay, it is representing an integrated circuit. It's just a symbol with this shape. Okay, just a reminder. Okay. So we have different. Remember that we have different integrated circuits. I'm going to move. Okay. Remember that with this external shape, we have different logic gates. These are symbols, and this is a photograph. Okay, this is a graphical image. With the same external shape, we may have an AND gate or an OR gate. Okay, in this one, in the output, is going to give me 5 volts in the output in case I have simultaneously 5 volts in two inputs, and A and B. 5 volts in A and in B, I obtain 5 volts in the output. In the case of the OR gate, I obtain 5 volts in the output if I have 5 volts in input A, or if I have 5 volts in B input. So here and this OR. This one is different. The NOT gate. In the NOT gate, I obtain in the output, just the contrary what I have in the input. So if I provide 5 volts in the input, I obtain 0 volts in the output. Okay? So these 3 basic logic gates. And by combining these two, and with NOT and OR with NOT, I obtain the NAND gate and the NOR gate. The symbol has this circle here representing that it is a combination of the AND gate and the NOT gate. And this symbol with this circle here is representing that it is a combination of the OR gate and the NOT gate. Okay? So 5 different types of logic gates with different responses in the output depending on the inputs. Okay, so going back to the examples. Here the need that I have, la necesidad que yo tengo, is to have 5 volts applied to the motor if I have 5 volts in A and 5 volts in B. I cover that need with an AND gate. This is the truth table of an AND gate. Okay? Remember, I obtain 5 volts in the output. Here the S is from the salida in Spanish. Okay? So I obtain 5 volts in the output if I have 5 volts in input A and 5 volts in input B. Okay? The one of the escalator, by default the motor is rotating. Okay? Here you have that by default the motor is working. But the need that I have is to stop the motor just in case I press A or I press B. So you have realized the need is completely different. I fulfill the need using a NOR gate. Okay? A NOR gate. Remember, a NOR gate is a combination of the NOT gate and the OR gate, this one. Okay? So by combining these two, I obtain the NOR gate that give, in case I don't press A or B, 0 means not press, this 0 means not press. I obtain 5 volts in the output, so the motor is working. But if I press any of these two, for example, in this position of the truth table, if I press B, the motor is stopped because I have 0. If I press A, the motor is stopped, the motor is 0. And if I press both, if two people want to stop the escalator is off. Okay, so this is the need that I have. Esta tabla sería la representación de la necesidad real que yo tengo. Okay, so this is the need that I have, and this is the integrated circuit that will fulfill this need. Y esta es la representación del circuito integrado que va a cumplir con esta necesidad. Okay, this one is the escalator. Questions. Okay, so I will address some questions for you. Lorenzo Vino, are you ready? Are you with us?
Yes.
Okay, so question for you, Lorenzo. Which of the two schemes represent the operation in a two-hand control? Remember that the two-hand control is this one. Okay.
Pero es que no estás compartiendo pantalla, creo.
Joder,
no me sale.
Okay. You should have told me. Porque no me lo habías dicho hasta ahora, macho. Vale. Veis que os estoy hablando y no estáis viendo nada. Joder, por decirlo, tíos. Fallo ha sido mío, pero... Vale. Okay, so question for you. En serio, si esto dependiera de vosotros, o sea, actuar como si de verdad os importara, porque de verdad os debería de importar. Si no, estamos haciendo un pan con buenas tortas. O sea, llevo 15 minutos hablando al vacío. Se me queda una cara de imbécil que, en fin, como digo, no he sido yo el que no lo he pinchado, me doy cuenta, pero me podéis avisar vosotros, profe, estás explicando y no estás compartiendo pantalla. De todas maneras, gracias a ti porque me lo has dicho, Lorenzo. Probablemente si no te hubiera preguntado no me hubieras dicho nada. Venga, Lorenzo. Okay, so question for you. What scheme represents the operation of a two-hand control? Remember that the two-hand control is this one. Okay? Where the motor has to be activated if I press A and B at the same time. So, Lorenzo, question for you.
Yes. I think it's B.
Look here. This is the symbol of an AND gate. The motor has to be on if I press A and B.
Okay.
The ball is representing a negation. Okay, that is the contrary. So this one is an AND gate and this one is a NOR gate.
Okay.
Remember, I have shown you this one is the one that I'm representing, an AND gate. The motor is on just in case I press A and B at the same time. Okay? So what is the right answer? A, B? A. Good. Next question also for you, Lorenzo.
Okay.
What would happen if the operator press button B? The first one, the press is not going to work. The press is going to work until the button is pressed again. A one is obtaining the output, which make the motor work, the press is going to work. Which one do you think is
I
the
think
right?
it's the first one. The press is
The
not
first
going
one,
to
yes.
work.
The press is not going to work. Okay. Another question for Aaron. Aaron, are you with us?
Yes.
Okay, so question for you. Here we have the escalator. Remember that in the escalator, by default, the motor is rotating all the time and will be off just in case one of the two push buttons is pressed. So the question is, which button or buttons must be pressed in order to make the escalator work?
Both of them.
Look the question carefully.
So neither of them.
Neither. Okay, by default the escalator is working. Okay, these push buttons are emergency buttons. Okay, so this one is the right answer. Okay, question also for you. Which scheme simulates the operation of both buttons in the escalator?
The A.
A, yes, very good. Which one is this logic gate? What is the name? The name of the. You have to learn by heart this. Okay. You have to learn by heart these symbols. So, what is the symbol? What is the logic
NOR.
gate? The NOR gate. Very good. Okay, the NOR gate. NOR gate. So the right answer, which scheme represents, is A. I think it's A. The escalator, yes. A. Okay. Okay. Now we have a more complicated situation in the case of an elevator. Okay. In an elevator, the motor only works if we have the combination of three different situations. For the motor to be working, we have to fulfill that both gates has to be shut. Okay. In looking to these micro switches, this 0 means that the door is open. Do you see here the switch open? Okay. So for having the motor working, we need to have A and B in a closed position. Okay, that what is the same with one state here and one state here. This is condition number 1. Okay, so for the motor of the elevator to be working, both gates has to be in the 1 position. This one is an AND gate. Okay, if I have 1 here, one here, I obtain 1 here. Okay? If either of these two is in 0, I obtain 0 here. So the motor will not work. But the next condition is that this person press the button C to move the motor. Okay? So in case A and B are in the 1 state and C is also in the 1 state, is the only combination for having the motor working. The only way for fulfilling this need is to have two logic gates, two AND logic gates, and one after the other, sets like this. Okay. So in the case of the elevator, let me show you some. Okay. So in the case of the elevator, the motor only works if the 3 conditions are in the 1 state. Is it okay? Do you understand? Any question?
No.
Okay, good. And for example, another example where we use logic gates is in the system for having an alarm, a light of an alarm, telling the driver that any of the 4 gates is open. Okay? In this case, we are using 3 different logic gates. Again, the same. This is representing a micro switch. A micro switch is this, okay? This lever is activated by the door. When we close the door, this lever is activated and then we close the switch, okay? We use them in many places, in the gates of the elevator, but also in the gates of a car. So A and B in the zero state means that the door is open. And C and D with the zero state means that C and D are open. If I close the door, I close the switch, so I have the one state in the inputs. Okay? So having one state here, if this were an AND gate, I will have one in the output. But since I have the contrary, because this ball is representing, remember that this is a NAND gate, and this one is a NOR gate. Okay, this is the NAND gate, and this is the OR gate. Okay, a NOR gate is going to give me 1 here in case I obtain 1 in any of these two, and the NAND gate is going to give me 0. Okay, if I have at the same time 1 and 1 0 here. So here, this is the symbol of the gate, of the NAND gate that I'm using here. Okay. What is the case where I don't have any alarm on? In this case, when all the gates are in the one state, when all the gates are open, and I obtain 1 in the light of the alarm in any of the other combinations. Okay. I have 1 open, I have 2 doors open, 2 different doors open, okay? So I have 16 different cases. If I have 4 doors, I have 16 different cases, but the alarm is off just in the case all the gates are closed. Okay, let's see in detail this. Okay, so this is what we have covered here. Okay, with 2 NAND gates and an OR gate. If in the case of having only 1 gate open, okay, if I have look here, this one is the NAND gate. Okay, the NAND gate is this truth table, and the OR gate is represented by this truth table. Okay. So in case I have 1 door open, just 1 door open, okay, if this logic circuit is in the one state, I obtain 0. 0 means off. Okay, this is what I want. I want no alarm to be here. But since I have 1 gate open, that is the D gate, this micro switch is in the 0 state. Since this is the contrary, because it is a NAND gate, is giving me 1. So if I have 0 here, but 1 here, using a NOR gate, the alarm is on. Okay? Just in the case I have all the gates closed, all the switches are in the one state, I obtain 0 here, 0 here, and in an OR gate, if I have 0 in the 2 states, I have 0 in the output. Okay? So we start with the questions. Okay, questions for Dario. Are you with us? Hello, Dario.
Yeah.
Okay,
Yes,
Dario.
yes.
Question for you. Okay. Question for you. Which row of the truth table will correspond to the image? Here we have 1 gate closed and the rest open.
So is B.
B, very good. Yes, B. Good. Next question also for you, Dario. What values should A, B, and C have in order to start the motor? Okay. To start the motor. This one is the one of the elevator. This one is the one of the elevator. These two are AND gates.
The last one.
The first one. Okay, good. Okay, question for Oscar. Are you with us? Oscar?
Yes.
Okay, good, Oscar, good. Okay, sorry. Question for you, Oscar. Okay, this one. Which scheme simulates the operation of the door opening the detector of a car? The car with 4 different gates.
A.
Yes, I told you 4 gates. Here we only have 3, so it has to be different. Okay, very good. And question for you as well. What could be the reason that the elevator does not move?
It's the second one.
The elevator doesn't move if A is not open, B is not open, or C is not pressed. So all the options are correct. Okay, all the options
Okay.
are correct. Okay, and this one, microprocessors. Okay, so the only thing that you need here to understand is that microprocessors, the ones that we use, for example, in a computer, are having inputs and are providing outputs, different outputs. Here you have the train of inputs. Aquí tenéis el tren de entradas, and depending on the input train, you have a different output train. This is how microprocessors work. Microprocessors in our computers. Okay. And question for you, Lorenzo. In an advanced microprocessor contains billions of relays, LDRs, diodes, or transistors.
Diodes.
Transistors. Okay. The transistors of a microprocessor are connected, forming
Bits sequences.
now BT is the information. Okay? They are logic gates.
Logic gate. Yes.
Okay, question for Aaron, question for you. Are you ready, Aaron?
Yes.
This one, the last one. We can find millions of logic gates in
A CD-ROM.
We were talking about microprocessors. We haven't talked about CD-ROMs. Not even wires. Okay, microprocessors. Okay, and the last one. Okay, I prefer you to. Hello, are you with me? Okay, so I prefer to devote the next time, the next 5 minutes or so, or 10 minutes, reviewing the mini unit in Technology, and please complete the dynamic version about this one of examples. Okay, you need to understand
Okay.
what you are reading. Okay, boys and girls, have a good day, and okay, complete the dynamic version. Is it okay? Any question?
No.
Okay.
No.
Thank you very much. Have a good day.
Bye.
Bye bye.